Hello, hi everyone, welcome to the Tech Brains channel. Today we came with a new video that we will get a SHA-1 key from a signed APK, how to get a SHA-1 key from a signed APK. So I have tried so many things while I failed so many attempts. So I have made a simple application that has one text view and one button. You can see code here. So this is a button click. When we click a button, we will get a SHA-1 key from that APK. So inside build.gradle app level file, I have added the view binding concept that enable true. So and also I have added the Firebase Crashlytics. Why have I added this? You can know later. So here I have binded my layout with my activity like this. Just getting the layout inflator. I have binded with my layout, and I have a click listener of the button here. So this is the logic to get when I click the button, this logic will appear getting triggered. So now this is the key where we get this method from this method, get signature method. So you can see I have two methods written in the bottom here. So that is used to get the signature of the app. That will not give directly SHA-1 key, just it will give an encoded string like this, what we have see on the right side emulator. So I have printing a log and I have printing the text inside the text view also. If we click that button, the latest hash code, latest means for one APK only one hash code will be generating. So each and every time we will get one hash code. This is majorly we used for API calls, to make encrypted API calls. We use this hash key most of the times, but this is not fair. When I tried this example, you can see here this package info. By using this package manager dot get package info, we are passing the package name and package manager dot get signature. So by using this signature, we are getting this package info object. If it is not equals to null only, we will get the signature. If it is null, we will just return a null. So because if it is equal to null means there is no signature inside the application. So whenever it returns null, there is no signature of the application. So if it is not null, then we will go with this method called signature digest. So I have written a blog for this total concept. If you want, you can read that also. I have given link in the description below. So these are the two methods that will give the signature. This is the second method, signature digest, that will pass the signature as a parameter, and we will get that signature as 2-byte array, and we will get a byte array signature. So by using that signature, we will make try catch blocks. We'll make simply try catch blocks here. So inside that we have message digest dot get instance passing the SHA-1 key as a key. Inside that we will create an object for message digest. So using this reference message mdd dot digest, we will pass a signature of byte array. So we will get another byte array called digest byte array. So from signature we will get message digest byte array. So using this digest, we have already talked about this base encoding. We have added already Crashlytics dependency. So if you want to read this, so we are using this method called base 16 method here in the last base 16 base encoding base 16 format we are using to get the encoded string. So this is the basics that this will return this variable. This is a variable which have object reference of the base encoding dot base 16 encoding. So by using this digest array, we will de-encode that and we will convert it to the base encoding, and we will return as a string parameter. So whatever you see in the right side on the emulator, you can see a hash code like hexadecimal format. So this is nothing but a hash key. So SHA-1 key we are converting into as an encoded string. Directly we cannot get SHA-1 key directly because it is a one-way encryption. So once it was encrypted by the APK, we cannot get the SHA-1 key directly. But I have a solution to get the original SHA-1 key, but not by this process. So everyone thinking that using and writing some Java code we will get the SHA-1 key from the application. No, we cannot get like that. We have another trick for that. I will show you that. First of all, uninstall the debug application. So now I will generate one signed APK for this project, and I will install it, and I will check once if it's showing the same hash key what we have shown on the debug APK or not. First we will check that, and later we will move on that second trick, how to get the original SHA-1 key from the APK, signed APK. So first of all we have to know things, how it will be works when we are using a project. So when we try to use this SHA-1 key, we have to know everything, when to use, where to use, why to use. So that's why I'm showing clear concept in this video. Don't skip the video. So you need to understand, for debug purpose we can only get only encoded SHA-1 key string. For released sign APK we will check that once the getting the APK, and we will install the APK inside the emulator, and we will check it once again, is that original SHA-1 key is getting or encoded string will be getting. We will check it once, and later we will move on with another concept of using APK tool, easy tool. We will decompile the signed APK, and we will get the code, decompile the Android source code, and we will try to get the SHA-1 key from that code. So we will make that also in this video. In this video it may be 20 minutes video, that I can cover the total concepts for explaining this SHA-1 key, when we will getting SHA-1 key, and where we will getting SHA-1 key, how to get encoded SHA-1 key string. So by using Java code we will only get encoded string with a SHA-1 key, not direct SHA-1 key. You should have to remember that thing. So now I have generated this signed APK for this project. Now I will install this signed APK inside the emulator. This is emulator. If you subscribe our channel, I will make more videos with using the Android Studio with multiple languages. I will use like Dart. By using Flutter I will make a Flutter examples. On the future I will make a Kotlin examples, so I can make Java examples. So I will make maximum so simply and superb applications with simple concepts with the depth explanation. So if you subscribe our channel you will get more concepts. So the APK was installed, I think so. Yes, it was installed. Now just click on that APK. Just the emulator is a little bit slow. Just click on the app. I think it was got stuck. No, it was not stuck. Just try to open this. Yeah, now it was installed. Now I will try to open the application. Yes, it will getting opened. So this is a signed APK we have installed in the emulator. When we click on this get key, so we have a text view called SHA-1 key. By default string is that when we click on a button we will trigger this get signature method, and we will run this logic, and we will get the SHA-1 key encoded string from the app. So you can see here I have got this string hash code in the encoded format. So I will paste it here in the notepad for clarity purpose. When we run a debug APK we have copied one string that we got from the application. So we have run a release APK, signed APK, we will got another key. So both keys are different. If you observe, that means for each application debug and release there is a SHA-1 key. Different type of SHA-1 keys are there. That's why the encoded string has been changed comparing to the release APK and debug APK. If you see that the same release code was shown here, when we close and open app also same encoded string will be getting, because it is a signed APK. So now I will try to uninstall this application, and I will show another examples like decompile the application and modify some code on that, and again we try to compile that application with using APK tool, and that recompiled APK when we installed in our Android app means we are getting same hash code or not? No, definitely no. But you can see the process when I try to decompile and changing that and again recompiling, and when I try to install the app means it will show different hash code. That means different encoded string it will show absolutely, because when we decompile an APK and recompile means definitely the SHA-1 key will be changed for that. So by using these three things we didn't see that original SHA-1 key where we can find. Yes, everyone had this doubt. So when we decompile APK and by using that source code directly we can get the original SHA-1 key. I will show you that process also. I will generate one signed APK, and by using that APK I will decompile that APK and I will get the source code of that APK. Using that source code I have one certificate file. Using that certificate file we can get original SHA-1 key with one single command. So you can get the SHA-1 key by using that trick. I will show the trick also in this video. As of now we are just confirming the debug APK and this key are same or not. Just both are same, because debug APK same hash code, same SHA-1 key will be generating. Release APK different SHA-1 key will be generating. If we decompile APK and recompile means that there is different SHA-1 key will be generating. But where to find this SHA-1 key? We will see this example. This is an APK easy tool. You can download it from Google easily. So after installing this is a portable, we cannot install, just click to run directly. So here we have a browse option to select the APK file inside of it. Just I will drag this APK inside the browse option. So after that I will decompile. I will click on the decompile option. The APK has been, the signed APK has been getting decompiled now. The decompilation process has been started. So we will wait some time. The APK will be in getting decompiled. After decompiling we will get a source code and we will try to get the original SHA-1 key from that code with easy steps. The video may be lag, but it will gives you clear understanding on each and every step. If you want what type of videos, you can comment on the comment section, so I can make the type of videos using Android Studio by using the three languages called Dart, Flutter and Java. Sorry, Kotlin. Dart and Flutter are same. Flutter is a framework and Dart is a language. So here we have got the code, decompiled code. So you can see the decompiled. I have written a blog also for this. You can read the blog also. I will give the link in the description below. So here is a command we will get here, that we will find a file called meta-inf folder. So go to this meta-inf folder and we will see that Android RSA file or cert.rsca file. There is maybe only one RSA file, maybe Android or certificate.rsca file. You can find it easily here. After opening this meta-inf folder, you can see the cert certificate.rsca file. Just open the command prompt here and just copy the command from this blog, where you can see that key tool print certificate file and that file name. So I will type the command. So to get more understand you by copying is just type the command key tool and print certificate, certificate not full letters, just cert is a certificate file, and we will type the file name as a path. We will see a file path as a cert.rsca file as a file path. Just we will type that cert.rsca. So just click on enter now. we will get the original SHA-1 key from this signed APK. Yes, hooray, we will got this SHA-1 key as easily as possible. Here you can see SHA-1 256 key original keys are getting from this signed APK by using this certificate file. After decompiling an APK, we are using this certificate file and we are using this command and we are getting this SHA-1 key from that. This is really amazing for getting the SHA-1 key. This is very dangerous also when we are using this SHA-1 key in the server side to encrypt the data. Means this SHA-1 key is getting easily by using this signed APK, by using this command. So next time we are using this SHA-1 key, we have to make some more encryption things we have to need to add, like RSA or some more encryptions like AES encryption, RSA encryption. We are generating the private and public keys and encrypting the SHA-1 key, encoded string with the public key and decoding with the private key on the server. That will make more sense of securing our applications from hackers. I think so it's very good idea to secure apps from the hackers, to make a RSA algorithm. So that's the best way to secure our applications where compared to AES algorithm. But RSA algorithm where encrypts only less data. That means we cannot encrypt the huge data. So we will uninstall this APK and we will try to regenerate APK from the decompiled source code. And if we try to install the APK once again in the emulator, means we are getting same encoded string or not. We will check this one also finally and we will close this video also. Already we got a SHA-1 key from an APK file while decompiling the source code. That's enough, but we need to check one more thing, that when we decompile an APK and when we change some source code in that APK and when recompile of that application, so when we get the same encoded string or not, we have to check this thing also. So we are compiling an APK of decompiled source code. So after compiling that, I will install that one also. Yes, signed successfully. I have compiled a decompiled APK to the APK. Again, we will go to this folder and we will open this recompiled APKs folder. Just open this. Here we can see an APK file. Just we will change this name to the recompiled test APK. Now I will try to install this APK inside the emulator and we will check that encoded string what we are getting is compared to the old encoded debug or signed APK encoded strings. Yes, I tried to install this application. Yes, it was installed successfully. When I recompiled any APK, means yes, it was getting installed, but when I try to open this application and when I click on button to get the key of encoded string, which type of string it was returning, if it is matching to our old APK's SHA-1 key encoded string or not, we will check now. Just click on it. We are getting a encoded string here. Just copy it and open a notepad here. So we have old strings here and we have a recompiled SHA-1 encoded string here also. We have debug SHA-1 key encoded string, we have released SHA-1 encoded string, and we are recompiled APK SHA-1 key encoded string. We are pasting it here. So have you compared with these strings? There is no match because there is different SHA-1 key. When you recompile the APK, means there is a different SHA-1 key will be getting generated with that APK. If we only want original SHA-1 key to crack from that, so we will use that with the command. When we recompile the source code and when we use that command certification key tool, print certificate and we use a certificate file certificate.rsa file. When we use that file to by using that command, means we will get original SHA-1 key. So hackers may get our SHA-1 key from the signed APK by using like this. I think I will not exposing the loop inside this trick. Just I am telling this trick to make your mind to getting some more security tricks to your Android app to that can be secure from hackers. So I'm just giving this video as a security improvement purpose only. Okay, thanks for watching.